Okay, today I am showing glitter in my tank. Okay, I made a really small tank and I oversaturated it. And I wanted to show you this glittery stuff. Now, what's cool about the glitter is the fact that at just the point when the glitter shows up, you usually get plate that looks like this. Okay, really amazing, puffy copper. Okay, and then in comes the glitter. And now I get to show you why that is on a Hall cell test. It's really sweet. So here's the initial Hall cell test I took of the liquid when it was getting this type of deposits. And if I put the ruler over the top of it, you'll see that that standard 0.1 amps per inch is nice and shiny. So it had a range from 0.34 to 0.11 amps per inch. So that's what you would set it at when you do your electroforming. Okay, so then I oversaturated my tank. And now you see, well, if I set it at that 0.1 amps per inch now, it wouldn't be shiny, would it? No. It would be a little bit on the verge of shiny, but dull. And that's glitter right there. So this would be the ideal part to get glitter. Now, if I just up it to 0.27 amps per inch, it would be shiny again. So there's two ways to correct this, in my humble opinion, and this is how I generally flow with things. So what'll happen is this will start going this way when it starts getting saturated with copper. This dullness moves over, and this area moves over. See? Boom, boom. Now, if I just recalculate to 0.27 or 0.34 amps per inch for a little bit, it'll move back. Why? Because then the deposits of copper get eaten out of the tank. Okay, now let me show you how I oversaturated my tank. Alright, so this is that little tank that I built, and it's great for just experimenting and causing all kinds of havoc with. How does one oversaturate a tank? Well, one, you could take and leave your anodes in your liquid without anything in it, and the acid will eat away at your anodes and then deposit that copper into your solution. That's pretty much the primary way to do it every time. Okay. The second way is you don't follow the 2-to-1 ratio. So I got this ring, again, this is a demonstration piece, and you would look at it and you're like, well, how many inches is this ring of surface area, right? And I did a video on how to calculate surface area. I would probably go watch it on YouTube, but I would estimate this to be about 5 inches of surface area. Okay, 5 inches of surface area. So if it was 5 inches of surface area, I would need 10 inches of anode. Okay. Let's say it was 6, I would need 12. If it was 2 inches, I would need 4. Do you feel the ratio? It's a 2-to-1 ratio. Alright. So if I would have too much anode, it would put more copper into the solution. So I could have to break this tank, all I would have to do is have, again, this is 5 inches of surface area. I would need 10 inches of anode. let's say I went and did 12 inches of anode. All right, that would be too much anode, and that would leach copper into my tank. See it? Very easy. Now, I didn't do that part. I did the, hey, I'm going to put my anode in there and leave it overnight, and maybe a couple days. I'll just walk away from it. And that's what happens right there. Cool. So now you know how to break liquid. So how do you fix it? Well, a natural way to do it, and this could get a little confusing, but I'll try to explain it. So I can now run my tank at 0.34 amps per inch, put this ring back in, and if it's, again, this is 5 inches of surface area, so I would need 10 inches of anode. I would now remove a little of that anode, maybe run it at 5 inches of anode. What would happen? Well, the extra copper will now go onto the ring. It would starve the solution of copper, and then it would balance back out, so now it runs in this direction. Okay, that's the confusing one. Option B, I could remove about 1/3 of the water and replace it with distilled water. Now the dangers of that is you could dilute your acid and upset your tank pretty bad. It's possible, and it will work, but it requires a little bit more maverick. So you're probably going to end up breaking your liquid for a while, and then it will repair itself, but you never really learned the balance of it. So yeah, that's option B. Both, and I make option B sound a little bit wrong, but it's not. It's just I don't prefer it, and that's what it is. You're feeling my opinion. So I like option A. I will crank up my amps, remove some anode, and let it balance itself out. And option B, sometimes I advise that for new people, and why that is because it's an instantaneous fix, and sooner or later you will learn, the anode dance, but I don't think you're ready for the anode dance, because option A is confusing, and option B is an instantaneous fix. Cool. So, I hope you enjoyed this video. I had fun breaking my liquid. And when things go wrong again, I'll run a little Hall cell test and make a little video. I think it'd be good for everyone that is in electroforming to visually see what's going on when things go south. Alright, you have a good one.